welcome to today's Build Hub class. And today we'll be looking over collections. So previously we've gone over the single data types, or rather the primary data types that deal with single entities such as strings, booleans, integers, etc, and we've gone over the various methods they have, things we can do with them, etc. Now we'll be going into the concept of collections in Python. Now, firstly, what are collections in Python? Well, just like the word says, you can think of collections as a group of items together. Okay? So while your primary data types deal with one type of item at once, like a singular entity such as x is equal to 5, we can think of collections as dealing with multiple of these entities at once. So keep in mind that while a single entity has to be in your primary data types, a single entity has to be of that data type. If you are dealing with a string, it has to be string. If you are doing integer methods, it has to be an integer, etc, etc. But with collections, you can have multiple entities or multiple singular entities that are of different data types, so they don't have to be just one data type, but it's ideal they are related. They could be related, they could be unrelated, but it's ideal they are related. But what am I saying? Let's give some examples of collections. So collections are of three or four types in Python. We have lists, we have sets, we have tuples, and we have dictionaries. So these four make up the types of collections we have in Python. But today we'll be focusing mainly on lists. So what is a list? A list is an ordered collection of items in Python. What does that mean? It simply means the items you put in a list, which are called elements. Keep in mind that every single item is called an element in a list, are in an order. That means they follow an order one after another. Okay, so how do we do this? We simply define a list, like my IntelliSense is telling us. We simply define a list using what we call square brackets. So these two square brackets are what denote a list. So whatever is within this list, we pass it within square brackets, and each of the elements, every single element, is comma separated. That simply means they are separated by commas. So let's say we have a list of cars. So we can say cars is equal to, let's just autocomplete, Ford, Volvo, BMW. So that simply means that each of these items are a type of car. They are within this list. They are an example of what is contained in this list. So if you notice, this list is assigned to a variable, or this list is called cars. So it's a good idea to name your list, or rather let your list be plural. The name of your list be plural, because obviously you are trying to represent more than one item at a time. And if you notice, each element in a list is comma separated. Now, if you print a list, Python gives you a representation of that list. So you are going to get this exact list, but you get everything but with square brackets. So let's look at that. Beautiful. So we printed it and we have this. But sometimes we might not want to have everything in a list. We might just want to access one character in a list. That is where we come into indexing. So indexing is the method to access an element in a list. Now, something you have to keep in mind is that the index of an element is simply its position within the list. So this is the first element, this is the second element, this is the third element. That's their index, their positions. But there's something you have to keep in mind with Python and virtually almost all programming languages. Python is zero indexed, in the sense that the first element has an index of 0. So the position of this is 0, the position of this is 1, the position of this is 2. You can think of the index of an element as its position minus 1. So this is the third item, so its index will be 3 minus 1, which will be 2, because it is 0 indexed. 0, 1, 2. So how do we actually access using an index? Well, we access an element using an index by passing the list name of that element, then the index into square brackets next to it. So this that I've just written is a representation of what is at the 0 index, which is the first element of this list. And the first element of this list is Ford. So this is a representation of Ford. But let's print it out to see what it gives us, just to confirm. Beautiful. So if we print this, we get Ford. We have successfully accessed the first element of that list by using indexing. So the same way, if we wanted to get the second element, we would use 1, because this is 2 minus 1. So yeah, like the IntelliSense rightly says, the output will be Volvo, but let's check it out. We get Volvo. Likewise, this would be 2. But there's something else you can do with indexing. In Python, the index of the last element is -1. The same way the index of the first element is 0, the index of the last element is -1. So you could access BMW as, since this is the third element, this will be 3 minus 1, 2. You can access it like this, which is BMW, but you could also access it using -1 because it's the last element of this list, irrespective of how long the list is. The last element has an index of -1. So if we output this, we should still get BMW. Beautiful. We still get BMW. Okay, so we've gone over creating a list and accessing a list, but how can we modify a list? So let's say we want to add something to a list. We have various ways to do that. The first way I would like for us to go over is called appending. Appending simply means adding something to the end of a list. So when we append something to a list, we add it to the end of the list. It becomes the last element in the list. So let's just keep this for checking sake. Now this is what cars is initially. Let's say we wanted to add Honda, like the IntelliSense is saying. So all we have to do is use the append method. The append method works by the name of the list, then dot append. So really quickly, let's look at the IntelliSense, or rather let's look at the documentation for that method. So it says it appends object to the end of the list. That's simply what it does. So it's a method. A method is simply a function you can do on a particular data type, because this is a list, so it has the append method. So you can do append, then brackets. Then what you pass in the brackets is what you want to add to the end of that list. So let's say you wanted to add Honda, like I said. Now we have successfully added Honda to the end of the list. But how do we check that? That is why this is here. So we're going to print cars again. Let's print cars before and after we append, just to see the differences. So if we run this, beautiful. Initially, this is what cars was: Ford, Volvo, BMW. But after appending Honda to the end, you notice that Honda has been added to the end of the list. I hope that makes sense. So that's one way you can add something to a list. This adds it to the end of the list. Equally, you could use the insert method. Now, how does the insert method work? The insert method works similar to the way the append method works. You just do cars dot append, or rather cars dot insert. But instead of passing one parameter, again, a parameter is simply what you pass into these brackets to a function. Whatever you pass to a function or a method is what we call a parameter. So instead of a parameter, one parameter, we're passing two things. First, we're passing the index we want to put it. And then second, we're passing the value. That's basically what's going on. We're passing the index and we're passing the value. So we're trying to append, let's say Toyota. So let's say we want it to appear at the index 1. So we pass 1, that's what we want it to be, then Toyota. So let's print cars before and after once again. Let's remove this and let's run it. So this is what cars was initially, like we know, and then this is what happened to it after we inserted. So if you notice, the index 1 represents the second element because it will be 0, 1, so that's the second element. So if you notice, Toyota appears second. But what happens to what was second before? What was there before? Because Volvo was there before. So what happens using the append statement is that anything that was in that position, or rather anything that was in that position or after that position, gets moved by one index. So if you notice, BMW and Volvo were either in that position, which was 1, or after that position, which was 2. So it gets moved 1. So it's like saying, hey, all of you move over, and then right here, Toyota comes. It's very easy to visualize. It's not confusing at all. It's the same thing. The same way, if you appended it to the end of a list. Now that one might be a bit tricky. So let's kind of look at that. Let's kind of look at that. I hope this was clear. Or rather, insert to the end of the list. Let's kind of look at that. So, like we said, if the last element in a list is -1, so if we insert it to the -1 position, let's see what happens. Beautiful. So if you notice, Toyota has been added, but wait, Toyota isn't in the last position, but we inserted it into the last position. How does that work? Well, let's analyze this. BMW was in the last position initially, yeah? And the rule says that anything you insert into that position or after that position gets moved by one index, gets moved next. So we're inserting it into this last position, yeah? So that means Toyota would get this position, but BMW will be moved one position after Toyota. That's simply what it does here. So Toyota is the last position, but keep in mind BMW wasn't just the last position. It was also index 0, 1, 2. So this putting it in the last position is the same thing as saying put it in index 2. And if we put it in index 2, that means it would be the third element. And since BMW was index 2 initially, it would be moved one index next. That means it would be index 3 and it would be the fourth element. And that's exactly what is happening here. So it might be a bit tricky, but the more you work with it, the easier it becomes. Okay, so finally, let's look at ways of, we have learned how to create a list, we have learned how to update a list. Let's look at how to delete list. Yeah, let's look at how to delete a list, or rather delete items for a list, since we are working with items. So how exactly do we delete things in a list? There are three ways actually. There are three ways we can do this. So I'll walk you through all of them. This is delete, that's the first way. This is pop, the pop method. Delete keyword, pop method, and then finally the remove method. So let's look at each of them individually. So if we wanted to delete something from a list, we would simply say delete, then we would call the name of the list, which is cars, then we would pass. It's just like accessing a list, except you are prefixing it with the delete keyword. So you are passing the index of what you want to delete into brackets. So let's say you wanted to delete Volvo, this would be 0, 1, so that would be 1. And then we're still printing cars after. So if you notice the before and after, beautiful. Initially we had Ford, Volvo and BMW, but we deleted what was at index 1, which was Volvo, and now we just have Ford and BMW. That's the first way. So let's comment this out. And then the second way we can do this is using the pop method. Now there's something interesting about the pop method. The pop method doesn't just delete an item, it returns the index. When we say return, we simply means it's a function that gives us a value. So once we have a value, we can assign it to a variable and manipulate it. So let's put that in practice. Of course, every method only works on a data type that has access to that method. So we would be using this cars list, since this pop method is for lists. So pop doesn't work with the item, it works with the index of the item we want to remove. That's my error. So let's say you want to remove the same thing with deleting Volvo, so you just pass 1 into it, and then this returns the index of the item you want to delete. So if we run this, Volvo is still removed, but this will return 1. So we can assign this to a variable and say removed item equals to this, and then let's print it. Let's print removed item. Okay, so this works opposite to what I said initially. So instead of taking in the item you want to delete and returning the index, it takes in the index and return the item that was removed. So we removed Volvo. That's basically how it works. We popped the item at index 1, which was Volvo, and then this returns that item that we popped. We assigned it to a variable, and then we printed that variable in sort of a formatted string, or just like an interactive sentence to see what it is. And we found out that we removed Volvo. So you can manipulate. This is very fun for manipulation and in programs. Okay, so finally let's look at the remove method. Remove method is very similar to the delete keyword. It's just a method, not a keyword. So the same thing, cars.remove 1, or rather cars.remove the item you want to remove. So instead of passing the index of the item you want to remove first occurrence of a value. So you insert the value and it raises a value error if the value is not present. So Contrary to what we have been doing earlier, that you pass in an index, here you just pass the item you want to remove and then you can remove it. So it returns, you pass the item you want to remove instead of the index, and then it removes it. So let's look at that, and it's still the same results we get using either one of them. So what you're going to use is just depending on your use case, what you're trying to do, what type of program you can build. So you can just play around with this and see how it helps you, see different implementations of this, because it's so fun to work with. Well, that's everything for today. Today we learned how to create a list, access access elements in a list, indexing, updating a list, and deleting things in a list. So thank you for watching. Thank you for giving me the time of your day. Thank you for listening. If you found this helpful, please like and subscribe, and have a wonderful day. I hope to see you in our next session.